Krantiji, shall we start or what's your take? I mean,
no, you can start. I have no issue.
Yeah, thank you. Good morning, everyone. So today we have Kranti Kumar Reddy from CPWD, Central Public Works Department, Executive Engineer Civil. So Kranti ji has basically done his master's from IIT Madras in Transportation Engineering. And then prior to that, he was PS from SVU College, SVU University in Tirupati itself. And then he joined Central Public Works Department in 2017. And he took the major, complete construction of NIT Andhra Pradesh. So an assistant executive engineer as that, and then got promoted as executive engineer and now currently handling the Hindupur project division in Andhra Pradesh. So prior to that, he worked in IOCL, NBCC, right? And the best part is that he is engineering service examination. He passed with an AR of 40, and prior to that, he got AR 33 in GATE, 2016 and 215 GATE 2013. So that's a impeccable record in its own way. So today we would be delivering the lecture related to the construction activities those were taken place at NIT Andhra Pradesh, 3 years prefab building system, which is very rapid construction as far as my understanding is concerned. So that way today he will be delivering the lecture related to these concepts, which will be mostly from industrial perspective to the extent expected. So Krantiji, the floor is yours. Please, you can please start. Thank you.
Thank you, Prasanna. So let me share my screen before.
Yeah, please. Maybe it's a good idea if you can share your video also, because students get a clarity. I mean, it's a good idea maybe if you can, if you're comfortable. So by the way, I have an issue in the camera. I'm now in a slightly different place other than the Tirupati for industrial purpose. So that's why it's not turning up. If you can turn on your camera, it would be great. Thank you. Students, you're also expected to turn on your cameras. So it's not, I mean, it would be better if the interaction is really, mutual. Please. Thank you. Thank you. Floor is yours, Kranti. Please continue.
Yes, is my screen is visible to you?
Yes,
yes, it's visible.
It's visible.
Yeah, Piyush, please coordinate it. Harita ji from CE department will be there. So at times, maybe because of this industrial visit that is happening, I may be not present. So I request you to kindly handle from the class perspective. Okay. Piyush.
Yes, sir. Okay, sir. Yes, sir.
Yeah, yeah.
I'll do.
Thank you. Thank you.
So is my screen visible?
Yes, it's visible.
Okay. So good morning, everyone. So myself, already they have introduced myself, Kranti Kumar. So I did my BTech from SVU University Tirupati, 2013 passed out, and MTech in IIT Madras in transportation specialization in 2015. And later on, I have appeared in engineering services 2016, where I secured 40 rank. And with that 40 rank, I have joined this Central Public Works Department. And these are my few work experience. And before joining CPWD, I was working in NBCC and I was working in IOCL through my gate rank. And finally, I joined in CPWD through ESC. So initially, during my first place of posting, I was posted in NIT Andhra Pradesh project. So where I was an assistant executive engineer, and I looked after this most of the part of this construction. And later on, I got promoted and I got posted to Hindupur at Palasamudram, near Palasamudram. So where right now I am looking after another project, customs project. So these are some of my selections in PSU, but I have not joined the things. So coming to this, so actually this NIT Andhra Pradesh, when we are given a task to construct this, they said they have to occupy the campus within 1.5 year span of time. They said to us, they said us there is no temporary accommodation for the people, so they asked us to construct very fastly. and they asked us to deliver within almost 1.5 year span, I think so. So if you want to deliver this entire campus, so what we did is we have divided into two parts, two phases. We have done this entire construction of NIT in two phases. And the first phase, they said it is sufficient to occupy and they can conduct the classes, all those things. So then it is very difficult if you go with the normal cash construction. If you use normal cash institute construction, it is very difficult for everyone. So what we did, we opted is we went for precast or prefab building system. So in this screen you can see these different elements. So can you see my arrow?
Yes, sir. It's visible, sir.
Yes. If you see in this system, this is the framing system. Okay. Where we will be having columns, beams, and this is the walls, and this is the staircase, and this is the foundation. This is the footing part. This is the stem column, and this is the footing. So what we did in this technology, when we call the tenders and we awarded the work, we got a company called Shear. These are the Pune-based company, and I have to give the courtesy. I have taken all these slides from their presentation to us. So here you can see this is the beam, and this is the column, and this is the wall, and this is the slab, and this is the staircase, and these are the walls, and these are the lintels or sajjas. So these are the different prefab components, structural components of the building that are casted at site. Okay. Before going further, I will show you one small video so that you will have an idea how it is going on, so that you can understand my presentation a little bit easy, because all you are just known about the theoretical parts. While coming to the construction, I may be using some terms, stem column, sajjas, all those things which may be new to us, new to you. That's why before going to this, all those things I will show you this video, so that it's a only 30 seconds video, so that you will get some understanding. So in this, you can see these are the columns, and these columns are the hollow columns. If you see, these are the hollow columns, and this is the beam part. Even this beam is not casted fully. So these are 75% of the beam will be casted at yard, and these are the hollow columns that are casted at the site. Okay, and they will be assembled at construction, and you just see this. So this is the way how the beam will come and rest on the column. If you see here, they have given a slots. So this beam will rest on this column. Similarly, the other beam, if you see here, whatever the development length you will be talking in construction.
We can't see the video, sir.
You can't see the video.
Yes, sir. The video is not visible.
It's not visible. Okay. So I have shared it, but
And now it's
Now I
visible.
can see.
no, it is visible, but I think so. Now it is not visible, right? Video.
It's visible, sir.
It's visible. Okay, chalo. Now
Yes, sir, it's visible.
yeah, see, these are the columns, these are the hollow columns, and these are the beams I am talking about. And these beams are not casted 100%. These beams are casted 75% at precast factory, and these are the hollow columns that are casted at precast, and they will be taking to the site, and there they will assemble using the tower cranes. Okay, and if you see, this is the beam that is casted. If you see, whatever this development length is there, LD, so they will be casting at site only, and there will be a sleeves in the column, and they will assemble at site. And during the site, to transfer the load from top floor to bottom floor, they will be using these dowels. This is the technical term we use to call. So these are the dowels which transfers a load from higher from top building, top floor to the one floor to the another floor. Okay, and these are the slabs that are casted at site, and these slabs are also I will be showing the site photos to you at later. So these are also casted 75%, and they will be keeping this steel. And these are the top reinforcement in the beams, and these are the top reinforcement, and they will be doing the concreting again inside the columns and as well as the slab. So these portion we used to call as a screed. Like once the this assembly is done, we will be doing the concreting. This term we call that screeding. So this is okay. This is the simple way how each frame of the building has been constructed. Okay. So now coming to this. So here what this Shirke has opted is this is the technology developed by the Shirke itself. So they call this technology as a 3S prefab building technology, where 3S stands for strength, safety, and speed. If you follow this three in any construction, strength, safety, and speed, you will be definitely. Hello. Okay. Sorry, I think so. I have to share it.
Yeah. Yes. Thank you, sir.
So now it is visible.
Yes, sir.
Yes. Okay. Sorry. So coming to this, here the technology whatever I have shown to you, that is the technology developed by the Shirke team. They call the system as a 3S prefab system, where 3S stands for strength, safety, speed, and sustainability. So if you follow the three at a time, strength, safety, and speed, definitely you will be achieving the sustainability. So usually this 3S prefab system comprises of mainly the structural components like column, beam, wall, which are the heart of the any frame structure. All these structural members will be casting at a precast or a casting yard, and they will be transporting from the factory to the site, and they will be erecting these structural elements using the tower cranes. But wherever when it comes into the foundation, that is where we call as a substructure, they will be doing a cast in situ. It is normal thing. So this is previously I have this is the small pictures where you can see this. If you see here, these are the walls and these are the slabs. On the slab, they will be putting the screed reinforcement, and they will be doing the screed. And again in this 3S fab system, there are two types of precast technology what Shirke is adopted. One is column beam junction. Column, it's a frame. It's a frame where you will be having slab. Slab will be resting on the beams, and beam will be resting on the columns, and the column will transfer the load to the footings. So this is called a framed structure, what we used to call normal. Okay, column, beam, framed structure. And whereas the other technology where they used is, they use these walls. Here there will be no columns. If you see here, there will be no columns. Only the slab will be directly resting on the walls. Okay, these walls are the precast walls. So this the load from the slab will be transferred directly to the walls, and wall will transfer load to the bottom floor walls, and that last floor, whatever the ground floor walls will be there, that will be directly transferring load to the plinth beams. This is the technical term. It's a nothing but of a beam. The beams which are placed at the ground level, they are called as a plinth beams. So these walls will transfer a load to the plinth beams. From plinth beams, this load will be transferred to the columns, stem columns, and from there it is transferred to the footings, and from footing to the ground. Okay, these are the there are two ways you can precast. One is by adopting the walls, and other is you can adopting the framed structure. So usually when where we use walls is, if suppose if you take any hostel building or where we have the repetitive nature, like all similar kind of rooms are there and spans are very less. So and height of the building is also very less. Then there we can use this precast wall. Otherwise, if we have a very large spans and floor to floor height is very high, there we can use this framed structure. So coming to this, whatever this 3S system they are adopted is, that is already validated by Building Materials and Technology Promotion Council, and which is a mandate by MOHA, that is Ministry of Housing and Urban Affairs. Okay, so using this technology, I think so they can adopt from any floor, from ground floor to G+25 stories. I think so they have constructed more than 60 million built up areas, SFTs. Okay, so these I already explained to you. If you see this, these are the columns. If you see, these columns are the hollow columns. Okay, and these are the beams. These beams also, they will be casting at 75%, and they will be keeping this steel open, and okay, and they will assemble at the side, and they will do the remaining portion. And these are the slab portion, these are the staircase portion, and these are the walls you can see, and these are the sajjas, where if you see for any window, we will keeping a sajja to protect from the rain. Okay, and this is, I think so this technology is a time tested proven technology in the construction. I think so more than last 70 years they have been adopting this. I have, and this is this slide shows that like over a years how the built up area they have increased using this prefab, because nowadays everyone want to have their buildings in a very short span of time with a very good quality, and because of this everyone nowadays they are adopting this precast technology. So coming to this, before going to the construction part, I have to say what are the some design assumptions that we are considered, and while considering designing of NIT Andhra Pradesh. So some of the things in this is these are the few conditions which we already kept in my tender. Based on this, he has to follow this construction. Whatever the foundation we said is that should be a minimum M25 grade. Okay, and whatever the up to foundation level, they should be doing the precast. They should be doing the cast in situ construction. Above that, they can adopt the precast, and we plan to design this entire campus for a 3-star Griha rating. Okay, and these are the few buildings in these are mainly the phase 1 buildings where they have adopted what type of structural system they followed. If you see, there are some buildings, if you see my CPWD office and laboratory, classroom complex, boys hostel, all those things, they adopted precast framed structure with AACC filler walls. Okay, and remaining these hostels, if you see, they adopted precast load bearing concrete wall slab structure. So which I explained previously, these two systems. Okay, and some of the quarters, all those things, mostly we adopted precast framed structure with AACC filler walls. Okay, these are the some minimum criteria. So for all substructure RCC, we used minimum M30 grade, and foundation we went up to 2.5 meters depth, where we having a safe bearing capacity of 25 tons per square meter. And all these things were arrived from the detailed geotechnical surveys, and we have designed for wind and earthquake as per the IS, and even the fire rated, all the structural members, all those things were we have considered for a 2 hours minimum fire rating, and whatever the condition it is Tadepalligudem. This project is at Tadepalligudem, which is near to the coast of Andhra. So we have taken a moderate exposure condition, and the precast composite structural elements, whatever I said, we have followed hollow core columns, precast walls, solid beams, and solid slabs, including staircases also. Okay, and I think so. These are the normal things which you will be studying in the your theoretical, and the same will be applied while designing any buildings. So one is dead load. These are the few dead loads as we will be applying as per IS 875 part 1, and live loads as per part 2. And these are the some material where we have used, and these are the unit weights, and all the occupancy classification, all these things has been done as per the standards. And these are the wind load we consider in designing of the buildings. So these are the minimum basic wind speed on a 50 years written period, 50 meters per square, 50 meters per second. And these are the coefficients which used to consider in wind load. These are taken as per the code itself, IS 875 part 3. And these are the buildings and floors, and what is the maximum height. Based on that, we arrived K1, K2, K3, and all those things. And based on this, they consider this wind load. And similarly, coming to the earthquake load, this Tadepalligudem falls under the zone 3. Based on the zone 3, as per IS 1893, all this detailing has been taken. What is the occupancy capacity, and what structure type it comes on, and what is the importance factor, okay, and how many residential rooms were there or not. All those things were taken from IS 1893. Okay, and here if you see the main difference, I will come back to this slide after showing these things. See, again, if you go with precast technology, there are two types in this. So one is, if you see the right side, these are called dry joint. If you see here, these are the joints that are directly placed on here, and there will be a small, they will be doing the grouting here. So these are the small, these are called dry joints. Okay, and the other thing is there, that is a wet joint construction. Okay, so if you opt for dry joint precast technology, this also you can do it very fast. But the main disadvantage with this is these are all non-ductile connections, where you cannot provide the ductile reinforcement. Like whatever the reinforcement you will be providing as per earthquake development length that should be going from beam to the column will not be there in the dry joint connections. So these are the other prefab. If you see on the right side, these are also jointed precast only, but these are dry joints which are non-ductile connections. At the same end, if you see the left side, which I have shown, so these are the hollow columns, okay, and these are the beams. At side, what they used to do, again, whatever the top reinforcement is there, they will be sending inside these hollow columns, okay, and they will be doing again concreting inside this hollow column, and they will be making as a solid column. First, they will cast as a hollow column. They will assemble at side. They will give the ductile reinforcement, all those things, whatever the ductile connection that is required, and whatever the reinforcement development length that should be going inside the column, they will be giving, and they will be casting again. They will be casting. They will be doing again the screeding. We call it as screeding. So with normal concrete, and they will make it as a solid column. Similarly, these beams also, they will be putting a shutter, side shutter, and they will be doing screeding on the slabs as well as the beams. So that after construction, if you see this construction, these are all look like a normal cast density only. So now come back to my previous slide. Here, all the connections we are doing with a self-compacting concrete or non-shrink grout. We will be not using any mortar. And whatever the moment resisting connections through reinforcement anchored into the self-compacting concrete or grouting of the adjacent members, we are not using any shear connectors. Where in dry joint connections, they will be using the shear connectors. In case of earthquakes, whenever there is any movement, horizontal movement, these shear connectors will transfer the load, which is very danger. If these things got broken, then the entire building will get collapsed. So again, this framework structure will have a complete structural integrity, because we are not building this like just like a pack of stiff cords, but we are doing the screed and making it as a again monolithic. That's why this after construction, if you see this will entire the structure will behave as a structural one structural only. Okay, and some the details of these connections, if you see, I will show you some slides where these connections will be connected. Okay, and these are the wet joints of the precast. So I said already to you, all these connections will be done with the self-compacting concrete. Okay, and coming to this is the master layout of Tadepalli Gudem, and this is the first phase. I have not updated this drawing. Okay, we have constructed the phase 2 also. Okay, so while designing the things based on the length of the building, this is a typical classroom building where if this is the normal in any building, any construction, whether it is a cash institute or whether it is in the precast technology. If suppose the length of the building comes around more than 45 meters, we used to go for an expansion joint. So similarly here also we will be going expansion joints. That provision also we can take here. And these are the things you will be coming to know all these design load combinations, what you study in the thing, the same they will be applying here. But here they will be doing the model entire things in the NITAPs. Okay, and these are the dead load combinations, which I no need to explain to you. And these are the some preliminary things. So for any building, when they are doing any structural design, first they have to do these framing plans. So there is a software called FrameWin. I think so. The Shirke has adopted a FrameWin to get the column sizes, all those things, and they will export this model to the NITAPs for the further analysis. Okay, and these are the models, NITAP models. They have see, when coming to the design part, there is no difference between the cast institute design and the precast design. Design always remains same. The way they are executing the things is different. Okay, so how a normal building will be designed, the same way the precast building also will be designed. Just like if you do in the NITAPs, so they will be having a column frame and they will be applying the dead loads, live loads, wind loads, earthquake loads, and they will do analysis and they will see these are the laboratory building NITAP model, and these are the quarters, staff quarters, and these are the staff again some quarters, and this is coming to the canteen building. So in this canteen building, the top we opted, this is the truss system. We have a truss and we have a GI sheets. Load from GI, it will be transferred to the trusses. The trusses will rest on the columns and the column will transfer the load to the footings. Okay, and these are the hostel buildings. If you see these things, these are all my framed beam column frame structural members. If you see here, this is the typical hostels where you see all these are the walls. Okay, these what are the red lines indicates each wall panel. So they will be casting at site, and they will accordingly they have designed in the. If you see here, there is no columns, only walls. RCC walls are there. The load will be transferred directly from walls and from walls to foundation. Okay, So accordingly, the way how you are executing, whether you are executing with the precast wall or column beam, accordingly your design should be there in the NITAPs. Okay, and this is the workshop building where we went with a pre-engineered building. We have not adopted the precast also. Why? Because here, if you see these, the column height, we have almost 6 meters. So it is very difficult to have a precast column of 6 meters, and casting at site is very difficult. So what we did is we went for a pre-engineered building. It means that it's like a composite structure. Inside this will be a I section. So this truss will be there. What you can see, right? Above this there will be a roof sheets, galvanized sheets. Okay, these galvanized sheets will be connected to the purlins. From purlin, the load will be transferred to this truss. From this truss will be welded to this column, ISMB columns, and these columns will be rested on the footings. Okay, so and finally we don't want this look. So what we did is these columns, entire columns, we used again a concrete to encase this, and we finished. Okay, these are the pre-engineered. I will show the final photos of this, and this is a typical classroom building. Okay, and this method of design, as I already said, there is no difference between the cast institute and precast. Same IS 456 will govern the design, and ductile designing will be as per IS 893. Okay, and these are the column reinforcement. They will be arriving using after analysis, whatever the load that is coming through the NITAPs, they will be considering this load and they will be designing. And if you see the beams, the column NITAPs will give the reinforcement that is required along the ends, middle. Okay, according to this, they will be designing the beams, and similarly according to the columns. Okay, and if you see now, if you see in normal construction, so normal cast institute, whatever if you see here, whatever the reinforcement it is coming here, we will be simply adopting here. But in precast, we are using like in normal cast institute, what we do is, so whatever the column reinforcement that is coming, we will extend to upward floor, and we will do the column, we will be casting the column at the same time. But since in a precast, what we are doing, this column will be casted separately and this column will be casted separately, and they will bring this column and they will be keeping here. So what they do is, first they will, what I already explained to you previously, at site they will be casting these hollow columns. If you see inside white, they will not be there. These hollow square columns will be there. Okay, so in these hollow square columns, they will be designed whatever the force coming at this section, right? For this entire force, they will be designing the reinforcement in this hollow column. All the reinforcement will be there at all the ends. It will be taken care of. Okay, so once they will place this hollow column, you have to transfer the load from top floor to bottom floor. So how you will be transferring the load from top floor to bottom floor? That is called, we will call this as a dowel reinforcement. Okay, so these dowels will be placed LD below the beam and LD above the top of the beam. Okay, so they have to design separately these dowels also. Just like column reinforcement, how you are designing, they have to design this dowel reinforcement also. How much reinforcement that is coming. So if you see this, whatever these dowels are there, these pink color dowels, okay, they will be designed for whatever the load that is coming at this section. If you see, if you go to the NITAPs, you will be coming to know that what is the load coming at this section. So based on this section, this reinforcement they will be providing. The same reinforcement they will be providing here, LD and depth of the beam plus to LD. So that, and the next precast column they will bring that side and they will keep on top of this. Okay, and before keeping this, they will do the screed. They will place a beams, and these whatever the white portion I am showing here, these are the screed. So they will be doing, and they will be casting all those things, and they will make it this as a solid, and they will make this also a solid beam. And now after this construction, it will entirely act as a one single component. Okay, and they will place a hollow column on the dowels, and same this thing will be repeated. Okay, this is where they do the column design. Okay, similarly, whatever the beam column joint, they will be doing they will be doing on the basis of strong column and weak beam, as you studied. Okay, and for these beams, again I said the beam reinforcement, all those things they will be taking from NITAP models only. And the precast wall slab, if you come to this precast wall, again it will be designing as per IS 456 with the minimum horizontal forces applied and 2.5% of the vertical. These are the connections at where they are giving, and they will be designing with the minimum eccentricity, which you have already studied, and the minimum moment of resistance of the wall they will be considering based on the slender sections, and what is the minimum reinforcement, all those things. I am not going in depth of this because these things you already study at your RCC design. And if you coming to this, if you come to this, the beam column junctions. So these are the some beam column junctions. Maybe you cannot understand these things. I will be showing this in the form of pictures where you will be getting. So these are the casting part that they are doing. Okay. Okay, let me explain through the images so that you can understand. If you see this beam column connections, these are the column. Okay, these are the hollow portions. Okay, so if you see in this, I think so everyone is visible, and are you getting my points, what I am saying? If you have any doubts, you can stop at me and you can ask if you are not understanding anything. Actually, I am busy in explaining, but I am not asking you whether you are understanding these things or not.
No, sir, we are able to understand.
Okay, if you have anything, if you have any doubt, you please stop me at any point of time and you can ask the things. And see, if you see this beam column connection, whatever the said white portion is there, that will be done during the site at site. Whatever these are there hollow columns, there will be a reinforcement placed as per the design. Okay, and they will be casting at site. Okay, and these columns, this reinforcement will come and sit here, and whatever the development length is there, that will be going inside. From here also it will be going inside. From this side also it will be going inside. Okay, and this will be done screeding. Okay, sorry. Similarly, this is the typical top screed. If you see the things. Okay, and similarly the secondary beams also, if this is the beam to beam connection, this is the beam to column connection. Wherever the secondary beams are coming, they should rest on the primary beams. So for primary beams, they will be giving a sleeve here. So usually when you are designing a secondary beams, will not take any moment. It will be designed as a just like a simply supported. So for this, they will be having a sleeve kind of things. Okay, whatever the secondary beam is coming, they will rest here and they will do the screeding. Okay, and if you come into this shear wall construction, so whatever the reinforcement from the column, they will be extending to here. If you see here, there will be a sleeve. This is the sleeves. Okay, they will whatever the reinforcement coming from the dowel part of time, they will embed it in this, and they will put this cutouts. They will be filled with the non-shrink micro concrete. So which does not require any curing, and it will not shrink also. Okay, so this is the way they will do, and I will show how the two walls they will be connecting. If you see the connection of these walls, so here there will be a wire loop. Okay, this is the wire loop. When two walls they are connecting, this side there will be a wire loop, this side there will be a wire loop. Inside this they will be designing with the reinforcement, and they will assemble at site, and they will this white portion, they will do this grouting at site, which is a non-shrink grout, which will not it will not shrink. Okay, so this is the typical two walls, straight walls. If you see, these are the perpendicular walls. Similarly, they will be doing like this. Okay, and these are three walls coming. Okay, and these are all the corner walls which is coming. So these are the reinforced. These are the looped wires. And inside this loop wires, they will make a design for the reinforcement, and this reinforcement will be through and through from top to bottom. So these will act as a one joint. Okay, this will it will bind this. There integrity between these three walls, and these are the precast slabs. So again, if you see, they will be casting 100 mm thick slabs, and they will be shifting to the side. They will be placing on the top of the beams, and remaining they will be doing the screeds. Okay, and this is where how they will be resting the slabs on the beams. If you see, this is the precast slab. This slab will be rested on the beam portion. This is the last beam. That's why you have L kind of things. Okay, so from here the top reinforcement will be going to the beam, and this is the beam main reinforcement, top reinforcement, and they will do the screeding. Okay, if you see, this is the from one line you can see how it is going from top to bottom. So from here the dowels will be bended to, if you go from bottom to top, if you see, this is the column, from footing column, stem column, it is coming. They will place the dowels, and these hollow columns will be placed, and they will do the screed up to half. They will do first, and again they will assemble these beams, all those things, and they will put the dowels again, and they will do the screed. Similarly, it will go on up to n number of floors. At the top floor, whatever the dowels are coming, these dowels will be bent into the roof slab, and they will do the screeding. Okay. So, and these are the standard codes which everyone will do while designing the things. Okay, and you can see these are the some tests they have already done. They have done some core cuttings to this column. If you see here, they have done the core cutting to the column, and if you see now, there is no difference between the precast and site wala concrete. It is almost looking like a monolithic, and these are the typical structures they have tested before getting certification from IITs. Okay, so these are the column beam. They did some load tests, all those things, and these are the some observations and findings they have given from IIT Bombay and all those things, and they have some research papers on this, and these technology have the patents to the Shirke only, and these are the typical field tests they are conducted from different places, and they in IIT Roorkee they have conducted this prefab system in a zone 4. They have a G+. If you see here, they have a framed structure for G+1 or G+3, I think so, and they have applied. They have simulated earthquake loads. Okay, and they have seen the behavior of this building in case of earthquake also, and they have a report saying that this prefab structure is well suitable for up to zone 4. They have given a certification from IIT Roorkee. Okay, so these are the some things they have given IIT Roorkee. Okay, so these are the few theoretical things that I have explained. So now let me let me explain through the side photograph, so that you will be understanding clearly. Okay, so that from a side point of view you will be getting all those things. So are you able to see my screen?
Yes, sir.
Yes, right? Yes. So if you come to the side, this is the
Yes.
Okay, are you able to hear me? There is no problem in my voice, right?
Yes, sir.
Okay, chalo. So if you come to the site, if you see in any site, this is must and required concrete batching plan. So where you will be doing the mixed design, and these are the silos where you will be having a fly ash on one side and cement on another side, and the coarse aggregate, fine aggregate, all those things will be there. And this entire equipment is called this concrete batching plant. Okay. And these are the fine aggregate and M sand or sand, whichever they are using. Okay. So coming to this precast, first I will show you the yard, how it will be. Okay. So these are the molds. The main advantage of precast is the same molds you can use. The repetition value will be like very much. If you use normal cast institute, we will be using the plywood shutters. So these plywood shutters, after 25-35 repetitions, there will be it will be damaged. But here you will be, the main advantage is it will not be damaged and it will be in a proper control shape. Okay, if you see, these are the reinforcement. Okay, whatever the hollow columns I said, right, they will be casting at side. These are the reinforcement, and they will be placing in this column molds. And before placing this, they will be dipping into the proto matrix solution, so that it will be a protection against the corrosion. And if you see, they will be keeping these things inside this, and they will, to maintain this hollowness, they will be putting these sheets inside this. Okay, and they will do the concreting here at cast. So see, this is the beam kind of thing. This is the beam mold, and then this is the beam reinforcement. And if any sleeves is required, they will be providing here, and they will be doing the concreting here. And the main advantage here is they will be having a shutter vibrators. Like if you see here, this portion, this acts itself acts as a vibrator. Okay. On top also, wherever there is no vibrators, and they will place this vibrator, and they will do this vibration. Okay. So these are the molds. Okay, after casting these molds, after 16 hours, they will be removing these columns, and they will be placing at yard. That's why if you want to remove these columns after 16 hours, it should gain the strength. So what they used to use is, they will be using a high grade of concrete. We used minimum M50 for minimum M50 for the columns, and beams and slabs we used M40. So these are the columns which will be lifted using the cranes, and with the help of cranes, and they will be shifting to the yard. If you see, these are the hollow columns, and they will be curing doing the curing at site for minimum 14 days under proper supervision. Okay, and these are the stacking of precast elements. And if you see, these are the columns, and these are the small lintels or slabs, and these are the small lintel beams. Okay, on the top of the door, they will be placing the small kind of the beam, because in order to transfer the load, we cannot transfer the load from brickwork to door. To avoid that, we will be placing a small beams. So those are called the lintel beams. We used to call lintel beams. So these lintel beams also, they can be casting the precast, and they will be keeping at site, and they will be doing curing. Okay. Now these are the way how they used to cast columns and the beams. Now coming to the slabs and walls. So this will be done in the factory, and this is the typical factory how it looks like. And if you see, these are the complete shutter, molds that are used for slabs and the walls. And if you see, these are the reinforcement they will be placing on the molds, and these are called lattice gutters. Okay, why they keep these lattice gutters is because if you see this entire thing, the main concept here is they want to design everything as a one-way slab. They don't want to design it is in a two-way slabs. They want the load to be transferred in one direction only. They don't want the load to be transferred in another direction. Because of that, they put a intermediate things. This will act as a two purpose. This one thing they can LX by LY one direction. This LX they can make it in one direction. And other purpose is these lattices will be used to lift these precast slabs. So these are the cranes. Okay, using these cranes they will be doing the concreting. So here from this batch mix plant, concrete transit mixer will bring the concrete, and the concrete will be transferred to these things, and the concreting will be done here. And here there will be a proper vibration with this shutter only. So these will be the things. And after 16 hours, they will be shifting to the side. Okay, and they will be doing the curing. Now coming to the foundation part. So this foundation will be casted normally only. This is a normal cast institute foundation. Okay, where you will be seeing the columns. This is the columns. And what I am saying is this is the stem column. The difference between the column and stem column is this stem column is below the ground level. Okay, so below this ground level, this is the stem column, and this is the reinforcement. In this only they will be leaving the dowels to the top. I will be showing the practical things. Okay, so these are the they will be doing the filling, and if any anti-termite is required, they will be doing the anti-termite. Okay, and these are the footing reinforcement and the stem column reinforcement. See, now these are the, see, if you see these are the columns. Okay, and if you see here, they will be leaving the dowels at side. Okay, so if you see here, this is the plinth beam coming on two direction. So whatever the negative reinforcement that is required, they will be taking from here to this beam. This is the beam. This is the bottom. I am saying. After this picture, this will comes here. Okay. So on this portion, whatever this portion is there, this will be doing the concreting with self-compacting concrete. Okay. So after this, the condition will be looking like this. Okay. So these are the dowels. What I am saying to you, and similarly, these are the dowels on the top floor. What they will do is they will bring the columns. They will place here, and they will do the screeding. And this is the typical first floor. I will be showing some other things. So these are the columns. They will bring these columns to the side. If you see, these are the dowel reinforcement. They will bring this hollow column. They will place on these columns, and they will make it an alignment, a proper line, level. All those things they will be putting. If you see this, they will bring these beams using the crane, and they will while casting itself, they will be having these sleeves, all those things. So the beam will come and rest at these things on all the sides. Okay, and they will see the plumb, line, and level of the columns and beams, and they will see all those things. This our said now, and from first floor they will be keeping on the dowels portion. Okay, and they will be doing the screeding. So okay, once the screeding is done, it will become like this, and again second floor columns they will bring and they will erect it at the side. See, if you see, this is the typical precast slabs. They will be bringing, they will be assembled at the, see, this is the lattice gutter what I am talking to you previously. They will be bringing to site using this lattice gutters only. They will be placing on the beams like this, and these are the negative reinforcement. Okay, top reinforcement here, and this is the development length as per the ductile detailing that will be going inside this hollow columns. And first they will do this screed column, and then they will do the remaining concreting. Okay, similarly the staircase portion also. Okay, if you see here, the staircase will be there. So there is a beam, and they will be resting on the beam here and here. Okay, if you see here, there is in this column, whatever there is a column, there is a sleeves. So the whatever the reinforcement will be having, it will be going inside this thing, and they will be doing the screeding. Okay, see, this is the typical things for the first floor. Whatever I said, the reinforcement will be coming, and for the top floor, you need to leave the dowels. The dowels will be placed at the site at this position, and they will do the screening. And after the electrical conduits, they will do entire screening. Okay. So this is what I said to you. They will be doing the screening with SSC, and they will be, if possible, they will do some vibration. Like even if you go with SSC, you will not be getting 100% self compaction. To avoid this, we will be using the vibrators also. Okay. So this will be the finishing that comes again. And once this is settled, maybe next day onwards, they can erect the second floor columns, and they can place these beams also. Okay, and whatever the frame is there, right? These are the column frame. And inside this, they will be doing this brickwork, AACC blocks we call, and these acts as a filler walls. Okay, these are the filler walls, and whatever the electrical conduits are required, they will be cutting inside the brickwork, and they will be placing these conduits, and they will be doing the plastering. Okay, all these junctions, they will be doing the plastering. And if you see the things after plastering, this will be it will look like this. Okay, so usually internal plaster will do 12 mm, external will be 18 mm. Okay, and we will be doing the flooring. This is called the flooring inside the building, and this is called the skirting. Okay, 150 mm skirting will be done. These are the laying of tiles, and this is checking the tiles whether any hollow sound is there or not, whether tiles has been placed properly or not. Okay. Similarly, if any retaining walls is required, we will be doing this retaining walls. And these are the few machineries that are required using the cast institute. Using, if you want to use a precast, these are the few tower cranes that are required. So if you see this, if I zoom in and if I see to you, this is the entire column, beam column framed structure. If you see, these are the entire beam column framed structure, and these are the AACC blocks. Okay. See here, you can see this on these columns, they will be erecting these things. Again, one more column. So this is what I said, the concreting will be done outside using the transit mixers, and these are some hydras which will be using for transporting columns from yard to your casting place. And this is some JCB backhoe, you know, and this is the bar straightening machine which will be used at site, and this is the EOT crane. Okay, and these are the compacting machine at site, and these are the few equipments, hydraulic platform machine, and this is what how we do the typically precast construction. Okay, let me share another thing. So you can see here, right? So if you have time, I can show videos of this. How is it visible? Hello? Hello?
Yes, sir. Yes. Actually,
So-
I was not able to hear.
Okay, you are not able to hear?
No, sir. Actually, my internet connection is bit
Okay,
wavering.
chalo, okay. So
Yeah.
I don't know whether I am boring all your students. I don't know.
No,
So,
sir. No, sir. It is quite interesting.
okay, this is the new technology which we have adopted. So if you have time, I will show some videos. It will be 5 minutes video. If it is okay, then I will show that small video, how the precast slab casting will be done and wall casting will be done. Otherwise, I will just show the photos. Whichever is convenient for you, I will do that. If you have time, I
Video
will...
is fine, sir.
Okay.
Yes. Sir.
So 1 minute. So are you able to see my screen?
Yes, sir.
Yes.
Yes,
Okay. I think so. This is the precast slabs, how they are casted. I think so. There is a 5 minutes. You can see how this bar bending steel they will be doing at site. So this is what they did at lattice. And I was saying na, in slab they will be having a lattice. They will be welding this. If you see this, I am forwarding this thing. So this is way how they do the lattice. So this is way how they will tie the slab reinforcement. Okay. So they will do this welding also. And they will place this lattice on the top of the slab reinforcement. And they will bring this slab reinforcement to these shutters. If you see this. Okay. Now, if you see, these are they will be doing concreting. So if you see this, there will be automatic vibration will be which is going to done. So this is the way how it will be looking after 16 hours, and using this they will be lifting this using the lattice. They will be this is the way they will lift. So this is the casting yard where they will be stacking this so they will be placing this rubber mats one above the other, and they will be placing on top of it. And they will do the curing for 14 days. Okay. This is the way how they cast the precast slab, and I will show you the wall also. Similarly, this is the reinforcement, wall reinforcement. These are the wall reinforcement. These are the molds. They are the wall reinforcement that are placed. And if you see here, that connectors I said to you, right? These are the connectors that are placed, okay, during casting itself. See, these are the things. These are the loops what I am talking to you. This will be embedded inside the concrete. Okay. and they will be placing the covers. Okay, on whatever the conduits that are coming, they will be placing.
Sir, video is not running.
This video is not running. Okay.
Sir, actually the video is not at, means it's not smooth. It's running, but with low.
No, actually it's a time lapse video. So, okay. It's a time lapse, and I am a little bit forwarding that also. Now it is visible. Now is it visible?
Yes, sir, it's visible, but
Not
it's
running.
still it's not moving.
Now?
No, sir.
Yes, sir. Now it is running.
Okay. So anyway, if you want me to share this also, I will share this. Okay. Similarly, concreting.
Sir, you're on mute.
Okay. So they will be placing a site for curing. The main advantage, if you see the surface of this, is it's very smooth. The proper line level will be there. Usually, which is not possible in cast sensitive. And these are lifting. These are lifting. Okay, they are placing on the trucks to transport to the exact site condition.
Sir, we cannot see your screen.
Sometimes it is visible, sometimes it is not visible. Okay, so this is what things. Let me. These are some photographs which I already showed to you. Now visible, right?
Yes, sir.
Yeah. So this is what the video which I shown. The same thing. The photos I'm showing to you. So they are making rough because when they are doing the screeding, right? So there should be a proper bonding between the old concrete and the new concrete. So to have that, they are making this rough surface. They will be placing aside. They will be curing. This is the slabs. See, if there is any wall door coming, they will be placing the sleeve like this. And these are the dowels. If you see from top floor wall, the load will be transferred through these dowels to the bottom wall. So these are the sajjas that are casted at side and they will be placing. This is the sajja, window sajjas. Okay. Now, simply these are the things I was explaining to you. These are the molds with steel reinforcement. These are the beams, beam reinforcement. Actually, these are the plinth beams. So that's why there is no any reinforcement coming on the top of the mold. But these are the main beams, first floor beams. Okay, that's why here the reinforcement is coming. And if you see the sleeves are there,
Sir,
and concrete.
we cannot see the photos, sir. We can see that folder, but photos are not.
Okay, again I have to share it separately or what? Okay, now is it visible, right?
Yes, sir.
Yes. So these are the molds what I am saying to you previously. These are the precast, and if you see here, there will be proper cover blocks will be there, and line and plumb of the beam will be exactly. Okay, if you see at Cash Institute side, it is very difficult to get this straight kind of beam, but here you will be getting these beams. And this is the beam reinforcement. This is what I am saying. Roof beams are floor beams, where we will be having the top reinforcement like this, and top reinforcement will be kept in this direction. Okay, these are the sleeves I am showing, and these are the concreting, and this is after finishing. So they will be shifting these things to the yard. They will be placing at yard. Okay, and these are coming to the columns. These are the hollow columns reinforcement. Okay, if you see, this is the mold and this is the column. Here, to make it to have a hollow, they put a mesh like this so that no concrete will go inside. Okay, and these are what I said, right? In this, there should be a proper planning. So if any column, any beam want to rest on this column, there should be a sleeve. So this is the sleeve they are providing. And these are the big columns, and this is the concreting. So they will be putting at yard. Okay, that's all. Now let me show typical building portion. Yes, now visible, right?
Yes, sir.
Yes, sir.
This is the normal, I said, foundation, Cash Institute foundation. Okay, These are the cast sensitive foundation levels. So all the dowels, whatever I said, right, they are living above the ground level. And they kept the plinth beams here. Okay, in this negative reinforcement they will be keeping, and they will do this junction concrete. Okay, here beam junction. This is the plinth beams. Here there is no any top reinforcement coming. If you see here. Okay. After finishing, this will be like this. This junction concrete will be done. Okay, and they will place the columns on the like this. With they will giving the prop supports, all those things. And after having the proper props, and they will be placing the beams. If you see the beam, there is a sleeves here. So they will be putting these beams. Above that beams, they will be putting these slabs. So these are the dowel reinforcement for first floor to second floor load transfer. And these are the screed reinforcement, what I said to you. Okay. And these are the negative reinforcement, and these are the top reinforcement of the beam. They will put the screed. Okay. And they will start the second floor. On the top of these dowels, they will be placing these columns again. And this process will continue. So by the time, usually if you take any normal cast sensitive, once if you cast the first floor slab, if you can clearly see here the difference between the first, this is the precast one, this is the cast sensitive one. Okay. So usually in cast sensitive, if you cast any slab, it will take minimum 14 days to de-shutter and to do the brickwork. But here the main advantage is where we are saving the time is one thing is when the foundation is going on, we can cast these elements simultaneously without waiting. Okay, once the foundation is completed, we can erect this within very fast. So this entire, whatever I said, right, this entire column screed first floor, I can do it in 7 to 10 days. Usually it will take minimum 20-30 days for anyone to cast the slab. But here within a 10 days of once the foundation is finishing, within 10 days I can cast this slab. That is the main advantage. That's why we are saving a lot of time. And after this, within few days, we can bring these blocks, AICC filler walls, and we can use this here. Okay, see that's what I'm saying. Once this slab is going on, we are almost completing these walls, inner walls. Similarly, this everything what we are saying, staircases also we are doing the precast only. And by the time it is completed, we can immediately go with the second floor also. See, this is the way we are doing the plastering. Okay. And this is the outdoor painting. And see, this is the thing. So these are some photos. Okay. If you see end result. So this is the final output. Now, can you say that this is if I show this image, can you say this is a precast or cast sensitive? There is no difference between functionality wise, all those things, but these things I can finish my building within 3 to 4 months and I can occupy this. This is my CPWD office, typical CPWD office. Okay. Visible, right?
Yes, sir.
Yes. These are the wall construction. Previously, what I showed you is a column beam, and this is the wall connections, which I will be showing to you. This is a typical hostel block. So this is the foundation that we'll be doing. This is the foundation. This is the stem columns, stem column reinforcement. Once the column is casted, backfilling will be done, and they will be during consolidation, proper consolidation. If you see here, they will be leaving the dowels. Here also you can see these are the dowels. Okay, these are the heart of this thing. Okay, these are the dowels, consolidation, and they are doing proper consolidation, and they are placing the plinth beams. Okay. Okay. So these are the grade slab I am talking. These are the grade slab is casted, and if you see here we are in hostels. What we did is these are the toilet portion, and these are the accommodation portion. In toilet portion, usually it is very difficult for us to we need to run so many plumbing lines, all those things. So which is difficult in these walls. But here that's why we are opted again beam column frame structure, so that we can have a walls. You can in the walls just like we can do the chipping here, and we can put the plumbing lines. So these are the walls I am talking to you. These are the previously in my slide I have shown how these two walls are connected. Okay, these are the three walls. One wall is coming from this, and these are two walls. So these will be the things, and these will be joined. They will be doing the grouting with launching grout. So these are the things, just like pack of cards they are placing, but with a proper. These are the I said right, wire loop. Inside the wire loop, this is the reinforcement that is going on, and they are doing the grouting, proper grouting. If you see here, if you see my previous thing, here there is a gap. If you see here, these are properly grouted. Okay, and above this slab will be rested on here. Okay. See, once this is done, they can go to the top floor. So if you see here, this will be it will be done very fastly. If I say this entire building, this is the building I was showing to you. These are the wall portion. These are the column toilet portion, toilet block I am talking to you. Okay, and if you see how they are packing and how they are doing the fast things, so there is no plastering is required. All those things. Okay, that is the main advantage, and these are the finishings inside the buildings. Okay, if you see these are the things. So once the construction is completed, it will look like this. Okay, you can't believe we have started the erection of this in the month of December 9, and by the end of March, I think so, we have finished this building and we have handed over to my client, and we said without giving the roads, all those things, you can see here they have occupied this. So this is the way how fast we can do the things. And final campus, few campus photos I will show you. So I will not take much time of you. This is all. Okay. So this entire campus, what we are doing here is we have done using the precast only. All the things are precast. So something are there which we have done with normal cast institute, like underground sums, STPs. These are we cannot do with wherever the water retaining structure portion is coming. We cannot rely it on the precast. So we went for the cast institute. Okay. So these are the entrance portion. Again, these slabs, if you see, all those slabs is done with the precast only. So this is the things. This is the. You can see, right? Okay. So this is the typical library block which we constructed using precast only. So it is very difficult for any new persons to say that whether this is done cast institute or precast. This is a typical library block. So this is the academic block. This is also another academic block. On top of it, we kept a solar panels. If you see, this is the canteen portion. So this is the column frame, but this is the truss system what I explained to you. This is the GI sheets. So this is the library block. So this is the where our AC plant is there. Chiller, you will be getting centralized AC from this plant. And these are the workshops I am talking to you. So these are the finally what we said is this is the engineered one. These are this truss is there. This truss will rest on the I section, and throughout this I sections we did a box concreting so that it should not be visible. So once this is done, no one can say that what kind of structure is this. Okay, this is the composite structure. On top of this, we kept a solar panels. Okay, and this is what I am saying. This is the final my CPWD office, and these are the other buildings. So some other laboratory complex. These are other laboratory building. So this is the main administrative building. Okay, these are the some residential quarters, and these are the girls' hostels in NIT. These are all the wall construction. Whatever the previously I shown, that is a column beam, and these are the walls. Here you can cleanly see these walls. If you see, zoom the things, and you can see this is the panel, and this is another panel. All those things. So this is the guest house, and this is the director bungalow. This is also a precast one. So all the buildings were precast. So this is the hostel, male hostels. These are the 4S, 2-seated, 1-seated, and this is the canteen for mess for them. And this is the second boys hostel, and this is the mess for this. Okay, and this is the auditorium, healthcare center, and SAG building, and these are the sports complex. Okay, so these are the few photographs, okay, of the final. And you can I think so, if you type NIT Andhra Pradesh, there you can see this entire video of this campus also. So I have done this video, and you can see that video, complete walkthrough video in YouTube also. So that is so I can conclude that, okay, this is how we did NIT Andhra Pradesh construction, both 2 phases. We have finished in the span of 3 years. It should be finished in the almost all 26 months or 28 months. We should be completing entire campus, but because of COVID, it was little bit extended because of the COVID. All those things we finished in. We started this construction in the 2018 September or November kind of thing, and we finished in 2021 August, and we are handed over these buildings to entire client, and now they are properly using these buildings. Okay, thank you. So this is what we did in NIT Andhra from my end. So now if you have any questions, you can ask me. Hello?
Hello, sir.
Sir, it seems
No, it is.
hello.
So from my end, it is completed. If you have any doubts regarding the precast, all those things, you can ask me. Okay.
Hello, sir. Good afternoon.
Yeah, good afternoon.
Yeah, it was a nice presentation, sir. It was like very good knowledge sharing for us. Sir, I have one doubt, like how much cost variation will be there between the normal construction and this prefab construction?
See, coming to this, there will be a little, see, if you are doing on a mass projects, I will not say about individual small buildings.
Yes.
If you go with a large campus construction of these kind of things, right?
Yes,
Your
sir.
cost will be almost all same end, or precast will be costing little bit less. Why? Because we are having a, if you see whatever the construction I am showing in this, right? So where usually you can see a lot of shuttering material will be required, lot of scaffolding material will be required in normal construction. Okay, but here you are avoiding all those things with a single mold. You are casting n number of columns, n number of beams, n number of things. So in this precast, see, if suppose if a new company want to come into this precast, it is not possible for them to come in, because the molds, all those factory, all those things, right? It will, initial cost will be, lot of cost will be there. But if you have your own material, so now my previous contractor Shirke, they have their own material, all the casting yards, all those things, they are their own material, towering cranes, all their own. Because of that, they will save a lot of cost in this. So if you want to hire this and if you want to do it, it is not possible. In that case, the precast construction will cost you very high. And one more thing, the transportation cost, if you see in entire campus only, they have their factory. So it is very easy for them to shift structural members from cache to site. So transportation cost will be very less. But if the factory is somewhere 60 kilometers or 80 kilometers far away, and if they want to bring from there, how to do the things, it will be little bit costly. And but at the same time, if you want to construct a large campus where you have a large acres, we can allow the precast factory to be constructed within the site. And in that cases, precast will be, I think so, 5 to 10% less. It will be cost less only. But if the precast factory will be there at far away from 100 kilometers away, and if you want to do this, I think so, it is not a better idea. Like cost will be definitely 10% more. It depends upon the situation where you are using single building, or you are going with the mass development campus kind of things, or not. Okay.
Sir, like since that factory you said it is inside the campus.
Yes.
So like like after seeing your presentation, I think that the material would be the same, like whatever the material
Yes.
used for the conventional construction, this construction should be the same.
Yes.
Mainly we are saving the cost in the shuttering and the
Yes.
form work, and also the labor.
I'm talking about the labor.
Yeah.
See,
Yes.
how much labor it is required in cash sensitive is you cannot expect it. Okay, but here few people with well skilled laborers are required here. In normal construction, without unskilled also they can do, but here only skilled persons can do. Without skilled persons, they cannot handle this precast one.
And also there is a technology like shear wall technology. Like what made you to go only for this prefab when compared to
the shear
that?
wall technology is nothing like that. The shear wall technology it's also a cash sensitive only. See,
Yes, sir,
here,
yes, sir.
if you see my wall, that is also shear wall only. See, the terminology is the same thing. See, you are keeping one wall on this is the shear wall. Whatever the wall construction I shown is, right, that is the shear wall only. And this is also a shear wall. The two shear walls is placing one above the other. Okay. The load is transferring from this wall to this wall only. Here there is no column. The same thing I can do with shear wall in cash sensitive, but I will be leaving the reinforcement from bottom to top, and I will be doing the shuttering, and I will be casting at a time.
Yes.
So
again, the labor cost would be yes.
Okay. So shear wall you can do it in a cash sensitive or precast also. You got my point, right?
Yes, sir. Yes, sir. Thank you, sir. Thank you very much.
So any other thing?
Hello, sir.
Yes.
Thank you for the wonderful presentation, sir. Sir, you said something about lattice reinforcement in prefab slabs.
Yes.
Does it have any design
No,
provision?
nothing.
It's
just an element. Whatever the slab you will be designing, with the reinforcement only. This lattice they kept only for two purposes. One is to avoid two-way slabs. All the slabs are one-way slabs only. Okay. Another purpose is they want to lift the slabs. For lifting purpose, they cannot lift the slab at one point. Okay. The cracks will occur. They have to have a uniform points. Okay. That's why to have that 9 points, they use 9 points and they pick the slabs. Okay. For that purpose only they are using. That is not a they are not designed for any load carrying, nothing like that.
Okay, sir. So that is not any structural number.
It is not a structural, but anyway, once if it is finally embedded in the structure,
it will make the structure.
It will take its load, right?
Load. Yes, sir. Yes, sir. And
it is an undue advantage of that.
Yes, sir. Make the slab work in one way only.
Yes.
Okay, sir. And sir, do these prefab walls have hollow elements at?
No.
This
precast also, there are elements who are doing this hollow column, hollow also. They will be doing the hollow walls, and inside they will be doing this filling material, puffed walls they will be doing. But here they are using the solid walls only, and they will be using the solid walls. All the outer walls, what they did is they did a 75 mm brickwork inside these walls. Because to have a thermal comfort, if you sit inside the RCC, if you sit inside the entire RCC without AC, it will be very difficult. To avoid this heat ingress, what they did is, I have not said this point before, all the external walls in the hostel buildings, what we did is, they put a 75 mm solid block, so that to have a proper thermal comfort.
Okay, sir. Sir, but in the pictures you have shown, some dowel bars are coming at the corner. Yes. Dowel bars coming out of the walls at corners. And how do they fit in the walls in the top floor?
No, actually, whatever the dowels they are leaving, right? In the if you have seen my video properly, then they would have understood. There is in walls there is a sleeve. So again, there is a sleeve.
Okay, sleeves. Okay, sir.
Okay,
yes, sir.
So these dowels will be going into the sleeve, and that sleeve portion will be doing the grouting. Wherever the two walls are coming, right, there is a wire loop. I said here also there will be a wire loop. Okay, so in these two wire loops, it will be like this. This is a wire loop, and this is a wire loop. In these two wire loop, they will be having a reinforcement from top to. It will be going from top to bottom, and that will be doing the grouting. They will be doing.
Okay, sir.
Okay. One small disadvantage with this, which I have not said, is mainly with the precast walls. When you are placing one wall above the slab like this, even if you see, there will be a minute, small gaps will be there, which we cannot avoid it. Okay. During multiple rainy seasons, there will be a dampness occurring. So whenever we see a dampness, we have to do grouting at these junctions over a period of time. For all, if you do proper grouting over a period of time, it will be stopped. That is the only disadvantage with the shear this wall construction. But if you go with the beam column joint, there is no problem. There is no dampness problem, all those things, because everywhere we are having the framed structure just like a casting steel, and we are having a ACC block filler walls, and we are doing the plastering. But what happened with the walls, we are not doing any plastering kind of thing, all those things. And whatever the if I show the, I will share this share to you. Wait 1 minute. You can see this. You can see this, right?
No. Yes, sir. Yes, sir.
Yes.
No.
If you see these things, right? So these are the ones joints actually. So this, even though whoever do these joints properly, there will be a small kind of things when there is a heavy rains happening. There will be a small dampness which will be looking inside the building. Okay, So at this portion, wherever you see the things, again you have to do the proper grouting. Then only these holes will be completely grouted, and over a period of time this dampness will not occur. But we have faced this problem during the first 1-2 years. We have seen this dampness, but now after doing the groutness multiple times, now we are not facing any kind of problem right now. But initially we have faced this problem.
Okay, sir. Sir, after laying these slabs, prefab slabs, you said something about screed reinforcement,
yes.
and means, are we laying one more layer of concrete?
Yes,
over
one more
these
layer of
slabs?
concrete we are laying.
Then how do we ensure bond between these?
See, that's what I am saying. Now, previously also I said to you, let me share my screen. I think so you are able to see, right?
Yes, sir.
Yeah. If you see this is the roughness that you are having. Okay. That's why if you see, when I was showing this casting also, they are using the trowels and they are making the surface rough.
Okay, sir.
Okay.
These correlations are made during the fabrication itself.
Yes, during fabrication itself, they are making this surface as very rough surface.
Okay, sir.
So that's why when you put the screed here, it will become as a monolith. That is the main advantage of this, is that only.
Okay, sir. Thank you, sir. Thank you very much.
Yes, okay. And any other? Hello? Hello? Am I audible?
Yes, sir.
So if there is no questions, then
We can close this meeting, sir. Thank you so much, sir.
okay.
Yeah, thank you,
Is
sir.
there any other things, or can we close the session?
I think they don't have any more questions, sir. We can close this meeting, sir.
Okay.
Thank you, sir.
Okay. Thank you. Thanks for giving this opportunity to me. I should thank Prasanna. It's again a wonderful experience for me to share my last 3 years of experience, what I executed in my Tadipalli. I forgot all those things. Now, because of him, again, I am remembering all those things. And I should thank Shirke team. Like we are the one who is executing the things, but final execution is done by my contractor. Shirke, they have done excellently, and I should give the credits to them. And I have taken their slides only to explain to you. Okay. So, thank you.
Thank you, sir.
Okay.